Okay, today we are looking at a different question under fluid mechanics, and it happens that this question falls under Bernoulli's principle. Bernoulli's principle obeys the principle of conservation of energy, and it states that the sum of the pressure energy, kinetic energy, and potential energy is constant. And it also states that as pressure increases, the velocity also decreases. So with that in mind, let's look at the question. Say a metal plate is totally submerged at a dock, and the plate is attached to an underwater wall. One side is exposed to the river and to the flow of water caused by tides. The plate has dimension of height 2.3 meters and width 90 meters. If the current has a speed of 3 meters per second as maximum tidal flow, how much force will the water exert on the metal plate? So let's try to draw a diagram to depict what the question is saying, that the metal plate is attached to an underwater wall. Metal plate attached to an underwater wall. So let's depict that with a diagram. They attached a metal plate to it. Then this is the metal plate. This is the wall. So with one side exposed to the river, so there will be flow of water against the metal plate. So what happens? It will create a pattern so that the water can escape to the other side of the plate. Don't forget, say the height of this plate is 2.3. Let me increase the height for better clarity. The height of this plate is 2.3 meters and the width is 19 meters. So if you look at this plate, it represents a rectangle. So that will give us that falls under the area of a rectangle. So like I was saying earlier, as the water is flowing, it will create a pattern on the metal plate. So that means if I have a situation like this, so when the water is flowing, it will create a pattern. So it's flowing in this way with a velocity. So this is the plate. The water will now try to escape part of the plate and create a different section on the other side. So by doing so, it is increasing the area or the diameter or the dimension of the plate. So as water flowing, it will flow through this region, that is A, and this will have a diameter D, which will produce an area. So the flow rate here will be VA, which is velocity times area. While on this other side, water is flowing, it will produce a bigger section, which means a bigger diameter. So the flow rate here will also be what? A and V, which is of higher value. But if you look at the question clearly, the height to which the metal plate was attached was not stated. That means the kinetic energy, that means the potential energy of this place will be zero, because the height is not given. Potential energy is the energy possessed by virtue of its position, but the position of which the place was placed is not given. That means the kinetic energy, the potential energy of the plate will be negligible. So according to Bernoulli's principle, the sum of the pressure energy, kinetic energy, and potential energy is constant. So what is pressure energy? Pressure energy plus kinetic energy plus potential energy is simply constant. So what is pressure energy? It's pressure divided by density. So having pressure over density plus pressure 1, density, let's leave it as E. What is kinetic energy? Half mv squared, and potential energy mgz. So in fluid, or in Bernoulli's principle, the height is represented as Z. So velocity 1 and the height 1 is same thing as pressure 2 over density plus 1 over 2 mv squared 2 plus mgz2. This is what it states. So let's derive to have an expression for the pressure. So let's multiply through by density. If I do that, I'm going to have pressure over density times density plus 1 over 2 density mv squared plus density mgz. So you can see density will cancel density. So what are we having as expression? P plus 1 over 2 EV squared. Let's take the mass to be 1 for a unit mass of water flow to be 1. Here becomes 1 Here is also 1. We now have density G and Z. So since it says the pressure energy and kinetic energy and potential energy is constant, that means we are going to have P1 plus 1 over 2 E V square 1 plus, like I said, the height is not given, it's negligible. Let's take it as 0 equals to P2 plus 1 over 2 E V square 2. So like collect like terms by bringing P2 to this side and take kinetic energy to the other side. So I'm having P1 minus P2 is equals to 1 over 2 rho V squared 2 minus 1 over 2 rho V squared 1. So what is common from this expression is 1 over 2 rho, which is density. So P1 minus P2 will give us change in pressure, which is 1 over 2 rho into V squared 2 minus V squared 1. So this is the expression to calculate the pressure, since the height of the plate is not given. As we all know, the density of water, which is rho, is 1 grams per cm cube, which is also written as 1,000 kilogram per meter cube. That's the value of density of water. Then, what's now the area of the plate? Area is length times breadth, because the plate happens to be rectangular plate. What is the length now, or the height, is 2.3, and what is the width, or the breadth, is 19. So the area will give us what? 43.7 meters squared. So, and the maximum velocity, V max, from the question of the water flow is 3 meters per second. So with that, now let's use to find our change in pressure. So if I should apply that, change in pressure, from the formula we derived earlier, is 1 over 2 density into V squared 2 minus V squared 1. So let's substitute our values. Change in pressure is now 1 over 2 times. The density is 1,000, and the maximum velocity is 3 squared. So if I multiply and divide, my change in pressure will give me 9 times 1,000 divided by 2 will give me 4,500 Newton per meter squared. This is now the value of the pressure of water that is flowing against the plate. With that, now we can now determine the force. From pressure, we have pressure, or change in pressure, is simply force over area. What is that the force? Area times change in pressure. So my force becomes, what is the area? We calculated earlier, 43.7, and what is the pressure? 4,500. If I multiply, and that will now give me the value of the force the water exerts against the plate. So 43.7 times 4,500, that will give us 196,650 Newton. Like I said, to convert to kilonewton, nothing will affect the solution. So if I convert to kilonewton, I will divide it by 1,000. 196,650 divided by 1,000. That will give us 196.65 kilonewton. So that is the value of the force that the water will exert on the metal plate. So please support our channel by subscribing. Thank you.